All right, everybody, so for the second part of this video today, we're going to be going into the same concept of finding volume, surface area, all of those things of prisms, except we're going to touch base on some of the shapes that honestly are a little bit more tricky to go through and solve and figure out. So the first pretty common example that we're going to see is a triangular prism. So something like this, where we have a base that is an equilateral triangle. So all the sides are the same. And again, just to be clear, these trace straight down to another equilateral triangle on the base. And the difficult thing about this is they'll give you some sort of side length, maybe like 8. And that's it. And based off of that side length, you have to find the entire area, the shaded part of the base. So how do we do that? So that's what this video is kind of jumping into, is what do we do when we have what seems like not enough information to tackle the sides of a triangle? Well, if we look at this, we can make a right triangle by splitting this into two pieces. And when we do that, this side is an equal length and this side is an equal length. Half of 8 is 4. So we've actually just created basically two pieces of a triangle that look like this. And that's going to allow us to solve for the height from the bottom here to the top point here of the triangle. And with that, we can solve for the area. Now, the reason why this is tricky is because we're about to use the Pythagorean Theorem. 4 squared plus b squared equals 8 squared. A, B, and then C. Remember, C has to be across from the 90-degree angle. So what makes this challenging is this is an application of an old skill onto a new concept. So we have to remember the Pythagorean theorem to be able to do this. So taking a look through here, 16 plus b squared equals 64. Subtract 16 from 64. So we'll get b squared equals 48. And then just b, after taking the root of both of these, is going to get us 6.93. So now that we have this, we have to be careful. We don't want the area of this triangle. We want the area of the whole thing. So let's redraw this. And that's my advice to you. When you're done, go back to square one. Each of our sides is 8. We now know from the top to the bottom directly is 6.93. So the way that we find the area of this triangle is 1/2 of the base times its height. So in this case, we'll have 1/2 of its base times its height. So the area of our base now is 27.71. And that's just a single base, either the top or the bottom. So if we're finding our base area, we would just do 2 of those. So 2 times the 27.71, because again, there are 2 of them, a top base and a bottom base. So the total base area of this triangular prism would be 55.43 approximately. And then whatever the unit is squared. So that's the idea here. The biggest concept of the first part here is just remembering to use the Pythagorean theorem and knowing that you are allowed to split this into a right triangle with a base that is exactly half of the size of the entire length there. So again, if you have a side of 8, make it 4. If you have a side of 6, make it 3. Whatever it is, basically divided by 2. That's part one. The second thing that we're going to see here, just is kind of tricky for us, is trapezoidal prisms. And again, another situation, you have the same shape on both the top and the bottom. They're going to give you just enough information to solve, but what it's going to mean is that there's going to be some work that we have to do here. So usually they'll do something like just give us a top segment, and additionally they'll give us like one more piece of information. So maybe they'll give us from here to here. and they'll tell us that that is, let's say, 3. And based off of that, they might give, let's say, an additional angle. So if this is 30 degrees. So it doesn't seem like much. It actually doesn't even seem like enough. But if we break this down into smaller parts, it's going to be just enough to go through and do it. So let's take a look at just the base. So we're just drawing either the top or the bottom. We know this is 6. We know from here to here is 3. And we know that this is a 30-degree angle. So the way that we're going to actually be able to solve this is using that same information. We can solve for this side and this side. They'd be the same thing. Maybe we can call that x. We can solve for this side and this side. Maybe we can call those y. And then we know that this is 6. So based off of that information, we'll have enough to solve for the area of this trapezoid. So the first thing that we can do, though, is, again, make a right triangle. So take that side and basically cut it off. Have your 90-degree angle, your y, your x, your 3, and then your 30-degree angle as well. And this is why we do trigonometry. Sides like this, where it doesn't seem like you have enough, if you can just get an angle measure, you have enough to figure out each of the side lengths here. So we can start off by labeling. This is our opposite side, this is our hypotenuse, and this is our adjacent side. And based off of this, we can set up our trig ratios. So sine of 30 equals 3 over x. We'll start with that one. Cross multiply here. So sine of 30 times x equals 3. Divide both sides by the sine of 30. And we'll get x equals 3 over the sine of 30, which gives us an answer for x of 6. So that helps us here because now we know that that's 6 and that's 6. So that tells us an important piece if we're trying to find the perimeter, trying to add up all the edges. We also need to go through and solve for y now. So now that we know that our hypotenuse is 6, we can do some Pythagorean theorem. Y squared plus 3 squared equals 6 squared. And in this case, just start evaluating. 9, 36, subtract 9. We'll get y squared equals 27, just 27. And then we can take the root of both of these. So we'll get y equals, in this case, the square root of 27, which is 5.2. So now this helps us because we have 5.2 here, 5.2 here. We can redraw this trapezoid. This is 6. This is also 6. From here to here is 6. And I said down here we got what? 5.2. So 5.2, 5.2. So the entire base length here is 5.2 times 2 plus the 6 that we had initially, which gets us to 16.4. So that's base 2. This is base 1. And we still have 3, which is our height. So we can now use our trapezoid area formula. So area of a trapezoid, if we forgot that from earlier this year, is base 1 plus base 2 times height. We divide that by 2. So 1/2 of 6 plus 16.4 times our height of 3. So 6 plus 16.4, we'll do that first because it's in our parentheses. And then now we just have multiplication left, so we can go through and multiply each of our terms. So the area of either the top or the bottom is 33.6 units squared. We would again double that to find our base area, but the key takeaway from this lesson is that we can take things into their individual shapes, specifically with right triangles, and use all of the properties of right triangles that we've learned over the last few months to solve for those unknown quantities. And that's going to make a big difference about whether or not we can actually solve these questions or not. So if it looks like you don't have enough information to solve at first glance, what that probably means is it's time to break the shape down into smaller parts and solve for those smaller parts. And you will be able to do it, I promise. All right, team, as always, thanks for watching. questions, shout about. Definitely a little bit of a harder segment of the video today.